Well. So we're on again. Today's the 4th of April. Seems like a million years. And we're down at Nudgee Beach, so we're quite close to the airport, which is almost silent. And here's a very different shore, alright? So this is a big shore, and also the tide now is moving from neaps. When we were at Manly on the 2nd, we had neap tides, and the neap tides moving towards a full moon on the 8th of April. So that means the tide height is going to be increasing, and the tide's going to be going further out. So we've got a lot of shore exposed here, and we're going to take a look at it, and we do a bit of interpretation. Mangroves here are really big. I'll just shoot down to towards the south. There's Stradbroke Island in the distance, and there's a couple of large mangrove trees, and then a further stand down there. So we'll do a bit of an explore. We'll have a look at the redox and see what we can interpret. So I'm at the top of the beach just for reference, and there's a bit of a seawall there, so obviously not the full coast is sort of shown. And here's a excavation. You can see the water's seeping out from the sides of where I've dug, from the water table, that sand sort of slumping into there. And that's characteristic of this sort of muddy sand, which we'll call it. So if you have a look there, no strong redox, but a slight darkening as you go down. And the more I dig, the more it'll just fill itself in as the water seeps out from the water table. Alright, so no redox. Lots of shell grit, very small bits of coral fragment here and some shells. Interesting. Alright, we can do the water percolation test on this shore. See how we go. Might be a little bit slower. Let's have a look. Oh, what's happening? Well, I've just made a pool, a little puddle. Is it going to disappear? I don't know, not convinced. Seems to be staying fairly well. There's no hard sort of shield of algae which we had the other day at Manly. Remember those Lingbia mats on the surface, hardening up the substrate? It's gradually seeping away. But so we're intermediate between what we saw at Redcliffe yesterday and what we saw at Manly. Alright, so we've come about 50 metres down the beach, and now we're just in a zone where water is being retained on the surface of the shore, and there are ripples you can see, and those will be developed by a current. So current moving sand grains up. Generally, because the ripples are still here, there's no strong wave action here. It just signals as a current over this sediment, and then it's just moving in a sort of semi-random way, making these little ripple sets, and that's something we haven't seen at the other shores yet. So no doubt Dan will want to talk about that, but you can see that it retains water on the surface, so there's going to be habitat there for small creatures to live. The other thing to note is that it's not been destroyed by bioturbation, so soldier crabs haven't been through here chewing it up. I wonder where they are. So again, we've got ripples, which I mentioned before, and then if we look at the whole beach, there's a crab running away. Is that a hermit crab? There he is. If we look at the whole beach, you'll see there's actually built up of very large sand waves. So there's the small scale stuff, like these ripples in the sand, which are indicative of a current. And I think Dan would agree that the current will be perpendicular to the angle of the ripples. All right, so the current will be coming in through here, laying down these ripples. All right. And then on the larger scale, and in the same orientation, are these very large sand waves with very low amplitude. Sorry, down there. Dan can talk about that a bit. So large sand waves with low amplitude, same orientation as the ripples. So here we are. Near the top of the beach still, but it's certainly zone of saturation resurgence. And if I can put my glasses on, you'll see that there's a little black hole just there. And if we see a black hole, we can imagine probably either a darker sediment below. This is bioturbation going on, or bioturbation. There's a hermit crab wandering around quite quickly. Let's have a dig, see if there's any nutrient build-up in the sediment. Oh yeah, look, check that out. Pretty good. So we've got a dark layer. The top layer, the oxygenated layer, is still quite thick. And that's of course where all the little creatures are driven up into. And so the other day I made a mistake when I was talking about Manly. I misspoke. I said metazoans moving up. Anything that needs oxygen to respire will have to live in the surface. Hang on, there's two hermit crabs having a little set to. Just checking each other's shells out and now racing away again. So there's a lot of hermit crabs here. So either there's current action or wave action, but it's certainly got that redox layer, not as strong, and the sediment above it probably 2 centimeters, 3 centimeters. So all that 3 centimeters will be available for things that require oxygen and can't build a tube. So yeah, another 50 meters down the shore, and we're starting to pick up some trails, if you can see those. Glasses Tibbetts. So something moving around underneath the sand. One here. It's probably Polynices, leaden moon snail. Have a diggle at the end, see if there's something there. Diggle at the other end. Hopeless. Can't find it. It's run off somewhere. Anyway, I'm sure we'll find one sometime. Alright, so Tamara's just indicating a couple of holes that we found. I was going to dig these up, see if we can see whether there might be evidence of oxygen going down deeper into the sediment. As I turn it, hopefully there'll be some, you'll see the edge of the burrow, and going down at a larger shovel, you actually see those burrows penetrating into the redox zone. Try another one. There it is. Ooh yeah, so something's living deeper than that redox boundary, which is about there. So it's below that. Another one. Oh dear, I'm just destroying things. Put it back. So just it's been pointed out, this little snail that's cruising around. You remember we saw one at Manly the other day. This is called Nacerius, and it's a predator / carrion feeder, and again it's got its proboscis out, probing around, smelling the sediment, looking for food. So a little predator on this huge landscape. Look at it. Massive. Lots of small stuff going on though, including more hermit crabs. There's a little baby, tiny one there, birching around. Another one just here. So hermit crabs are part of this story. Another one there. Very high density. Great for a little project. Oh, we were asking about soldier crabs earlier on. They appear to be here. Let's have a quick little diggle, see if anything pops out. Come on. Play nicely for me. Oh, you soldier crab. Oh, he's gone. Alright, we'll keep on keeping on. It's a bit interesting. There's some very fine particles here. I was talking about the Hillstrom diagram the other day, and fine particles being very difficult to sediment out. Once they get very small, they tend to stay in suspension. Here it looks like we've got clay almost, but anyway. One for Dan, I think. Maybe it's, I don't know, I'm not going to think of an idea. I just don't know what it is, but there's this little line of it here. Someone mail me in an idea about what's going on here, please. Alright, I've got a theory, campers. So these are the ripples, and in between the ripples is waters left standing. And as you can see in this one here, the fine particles have fallen out into this area here. That's like that sludgy stuff I showed you the other day. So a lot of nutrients in there. These are things like detrital particles and that sort of stuff. And then progressively it dries out. So this one's a little bit drier. You can see it's a sludge now. And this one here is in the process of drying out until it becomes fully like a clay almost in this ridge here. One for Daniel. So the other day, and I found my booties, I mentioned about dilatancy and thixotropy, how that child's footprints had squidged into the mud so you could see the gaps between the toes. This is a different sediment, so if I pummel away, this is more dilatant, you can see the particles sort of lift up, they're staying together. So the more I do that, the further into the sediment I go as I displace the water. Alright. Anyway, I'll find a better example. Maybe. A few steps further and we can see evidence of some small creatures. I don't know what they are, but they're definitely living in the anoxic zone and they're doing the odd biotubation trick. And here, oh dear, it's quite small. You can see it here. There's a tube worm. Remember I spoke about baffles, like mangrove nematophores, seagrass, dune grass sitting up, slowing water velocity. Then worm casts in great number can lock the sediment together as well, and also they can slow down water velocity and help precipitate out particles by that Hillstromy thing I mentioned. Anyway, it's a little tube worm over here, it's flopping around. Good. Talk about tube worms. We just found a little cluster, and if you notice, here's a cluster of tube worm tubes, and around them, the ripple effect has sort of been taken out. So I think they're binding the sediment together, not letting it move. So more tube worms doing that baffling effect. Also here in terms of differential density, it's an interesting sort of sediment that you can see the sort of shell grit sort of fallen out. These are shell fragments, small shell fragments. They've been fairly well sorted by the current velocity here. It's almost like panning for gold, you know. The sediment particles make up this ridge. The sand is more dense than the calcium carbonate in the shells, and so as the water velocity drops, so those sediments stop moving, but still tiny particles like this can be moved around and then winnowed out into these rills, I suppose. So anyway, Dan will have a story on that. The black stuff here, it's not redox, it can't be. It's all well oxygenated sediment here. My suspicion is that might be rutile. That might be some of those rich minerals that occur in the sands, the sand islands and sand structures around Moreton Bay. Alright, carry on. Well, what have we got here? It looks like magic. There's a little island. Why is there an island out here in the middle of nowhere? Oh, it's the old worms again, doing their baffling, slowing the current velocity, doing a champion job, and again interrupting that ripple pattern. So this sediment is higher than the sediment around it, which you can see as part of this pool. So these worms have done very well, and as they've slowed water velocity, they've stopped that sediment transport. Sediment's fallen down there, remember Hillstromy diagram, and therefore there's accretion going on, vertical accretion. Pretty good. Other little worms around as well. You can see they've made their tubes out of a mix of bits of seaweed and shell grit and that sort of thing. I don't know the species, I'm not familiar with this shore. Anyway, onward. So, oops, I went too close. There's one of the worms just fallen out of its tube. Pop it back so it's all happy. And I'll dig another one up, see if we can find another one. Alright, run for cover. They're down in that anoxic sediment down there. I'll try and get a species for you. Put the little island back together. Alright, so another something. On large beaches like this, we're how many? 100 metres down? 200 metres? We're quite a way down the beach. Look at the profile here. It's getting shallower. What is that? So, yeah, on these large open shores, these gently sloping sandy shores, intermediate at wave energy, we're getting areas right down the shore that are actually higher than the surrounding environment, and probably close to where we were on the beach way back up there. So all that stretch of beach between here and there is basically protected by these bars. So the waves would break here. Once the waves break over here, then because everything else is lower in front of you, the waves will travel all the way in to crash against that. So we'll crash against the seawall, bump into the seawall. So that's how significant these bars are. They protect this shore, make it much lower energy than otherwise would be. I think you can hear the waves down there. We'll go visit those in a second. Okay, nice one. We just found an interesting thing. So these are the ripples I've been talking about. And as we move here, there are some lateral ripples. Something's going on with a lower current velocity. And so there's two current actions here. Maybe Dan can do some interpretation on that, but Tamara tends to think it's a different direction of current, and I concur. I'm not sure which is which though, which is the dominant one. Maybe the larger ones are dominant, and then the smaller ones form in between those as the water runs off this higher structure. Hello, hello, hello. Does anybody recognise this? Give me a few dollars if you recognise that. Actually, no, I'll give you a few dollars if you recognise that. That's Scopimera again. So that's the little crab that makes the balls. We're going to do another crab shot here. Probably another rubbish one, but anyway, let's see how we go. We'll line it up and see if we can walk away from Scopimera and see if Scopimera comes out and does what Scopimera is supposed to do. Alright, walking away. Ooh, sir. See any balls there? I don't think it works, you know. Mate, it's got too windy now with... Hello, there's a puppy. It's got too windy now, and the crabs are desiccating probably too fast. Maybe the sediment's too dry. But over here, Tamara's found a big patch of Scopimera. There might be others. Have a look. Look at this lot. These are unruly Scopimera. In most cases they're very neat and they deposit the balls in a sort of radial pattern around the central hole. There's a hole there. One there. So we've got fairly high density of Scopimera here. Again, I've got my glasses off. Dang. You can probably hear the wind. So there's a hole there, hole there, hole here, and a whole field of little balls from sand bubbler crab, Scopimera. I just scared a juvenile prawn out of the pool and he was hopping around. Are you alright? What's up? There he is. Pop him back in, shall we? Maybe an Eastern King prawn, juvenile, who knows? Pop him in there. Seems from right. There he disappears, goes straight into the sand. Invisible. A jelly? That's my word, what is it? I don't know. Okay, so Tamara just found a curly thing here, a little jelly-like thing. If we were to take that back and have a look under a microscope, you'd see lots of velager stages of a baby mollusk called Polynices. And Polynices, it's full of dogs here. Polynices is the lead and moon snail. And those are the trails we were seeing earlier. So, yeah, good one. Nice link. Another hermit crab. It's a hermit crab story, isn't it? It's bound to be a hermit crab story. Alright, onward and upward. So, anyone feeling a little tired? The only hard substrate I've seen out here, other than the tiny shell fragments, which wouldn't be very stable, we know from our interpretation of the ripples they move around. There's another hermit crab. Look, it's dragging some weed with it. What is it thinking? Oh, yeah. So this is the only bit of hard substrate for quite a substantial distance, and you'll see that there's a quite good growth of barnacles around it. Doesn't seem to be grazed over heavily, but there's not a lot of algal growth on the top here. So, if anything lives inside here, it's a great place to shelter, doesn't it, really? From all sorts of wave action. I don't know. Nothing. Anyway, so the only hard substrate for a kilometre or so, and it's a tire, and it's got some barnacles on it, and lots of algae though. Right, lots of algae. And I'll be remiss in mentioning that on this year, of course, we have seen no macroalgae whatsoever. No, can't think of any. But there'll be lots of microalgae here, so lots of diatoms in the sand. It'd be lovely to take a sample. Hey, there you go. I might wash my jar actually, get a bit of this stuff to take home, and I might see if I can find some myofauna for you. Anyway, off for now. How are we doing? We all good? Now our friend Mr. Crab here, which is a juvenile swimming crab, Portunus armatus. Loves the tidal areas, a bit of habitat too. You can see it just running around there. And it's found some carrion. It's got a baby crab, and it's gonna munch it. You can see the flat swimming legs at the back. Oh, there he goes. Bye-bye. Still see the eyes just there. Just leave him out if we want to. Hello, we found you. Doesn't want to be found. Alright, leave him in peace. Might come back and eat you one day. Oh, there's something. There's a bit of metal here. Again, it's got a bunch of tiny basically barnacles on the surface of it. Also, it's interesting to have a look at the shells. So if you have a look at the shells here, little valves are fairly well even. That one perhaps, not sure. I'm looking for signs of murder. No signs of murder yet. There's a little snail shell. Yeah. Lovely. But the only other bit of hard substrate we found so far. Alright, this is a bit of a cheat, I suppose, but this thing here is a leaden moon snail shell. But it's got a hermit crab inside it, which is why it's not buried in the sand. So that's, oh, hello, one jumped out of the sand there. It is a story of hermit crabs down here, I swear. And tiny shells. These little clams would be the target of those polynices, the leaden moon snail. They're predators. They cruise around looking for those little clams, and they'll bore a hole in them and suck the guts out. A bit like the mulberry whelks do on the barnacles and oysters. The amount of shell grit's increasing as we go down the beach, and the ripples are higher, I swear. But again, all perpendicular to the principal wind direction, kinda, well, at least the swell direction, which is supposed to be coming from the north. Is this north, I wonder? Yeah, I'll buy it. It's set on sea breeze, it'd be north. So north we have like yesterday, and those waves are rolling in, but breaking far out. We'll check out the edge of the shore very shortly, but these bars are going to be doing a lot of protection further close in. So we have another worm island, I think, unless it's seagrass. I think I'll get shot if I call it a worm island. It turns out to be some seagrass bed. So I'd better give it a little diggle and see what we've got. So, I don't know, I'm thinking, no. As I push through, I can feel the root systems. You can see the rhizomes here, runners and roots. There's that just seagrass bed. Oh yeah. Alright, there you go. That's the story. Seagrass. It's doing the same sort of thing the worms are doing. It's slowing the sediment velocity, trapping the particles, or slowing the water so the particles fall out. It's not its main mission in life, but that's what it does. And the seagrass here seems to have died. Seagrass, of course, relies on a lot of surface, sort of light punching through to the deep. Here, these are intertidal seagrasses. Probably Zostra, looking at the structure of it. Zostra capricorni, Zostra marina, whatever you favour. And this bed has seemingly carped it. But we're not too far away from the mouth of the Brisbane River. If I just sit up, you can see the cranes at the port just down to the south. So we're actually in a spot very near the Brisbane River. So water quality here will be quite mixed, and this seagrass bed may have extinguished. Poor thing, but the roots are still doing a bit of a trick, and the little bits sticking up are slowing the water velocity down, trapping the shells. And also slow the nutrient sediment turnover, so bioturbators won't be able to work in here. So the redox layer is going to be quite close to the surface here, as you can see that dark mud just barely a centimetre down. And of course, were the seagrass alive, it would be drawing oxygen down into the sediments. But yeah, so poor old seagrass bed. Actually, the area north of the Brisbane River has had a bit of a challenge with seagrass demise because of the water quality issues and the clockwise circulation in Moreton Bay. So the water from the Brisbane River gets carried north across these beaches and has done a lot of damage to the seagrass here over the years, but it's coming back. So we're right on the lower shore now. There's the bay, and then again we've got some discoloration just down here, so the sediment's getting slightly anoxic. You can see deeper down. We've still got a good 10 centimeters almost of oxygenated sediment, but yeah, interesting stuff. So there's a reasonable amount of nutrients in this stuff. I'll say why in a minute, I think. Okay, so now we're at the water's edge, and you can see that the wave action here is fierce. Look at that, crashing onto the shore. Or is it dribbling onto the shore? Who knows? What I do know is I'm about to get damp as it runs past me. But this area here, the energy here is much different to the energy out there, if you can see. So there's another bank out there, like this one behind us, and the waves are breaking on it. So once the waves are able to pass over, the swell's able to pass out of that, over that without breaking the outer bank, then they'll pass in and start breaking on the next bank, and so on and so forth. So while this shore has, you know, substantial exposure, this is a northerly, so it's got all the fetch it wants right past the tip of Moreton Island, which is just over there in the distance on the horizon. Then despite that, and how much wind? 25 kilometers an hour, something like that, about 25 k's an hour, we're just getting ripples coming in, and that's going to drive the structure of this beach, making these ripples. Alright, so I think we've got an answer for the ripple structures, and we can get Dan to have a think about that one. You'll see the ripples forming here actually as the sand is pushed back and forth by the very gentle action of the waves here, and again perpendicular to the angle of attack of these waves. Or do you call them waves when they're that big? Ripples? Anyway, here they come. Alright, good. So we're right down on the edge of the shore here, and there's a little hermit crab. A little hermit crab just there. There he goes, starts running around. So the tide's actually covering him now. And then the tides, there's the swash running out. You can see the little bees around him. Quite happy here for a tiny little animal and a little calcium carbonate shell. So this is a low energy beach. But there's pretty good sort of sorting. I talked about sorting the other day. And as you've seen as we walk down the beach, the sediment's pretty uniform on the way down. They're pretty much the same sort of thing all the way through. And it's all about this, all about that process, all about the water. He's heading out to sea, so we'll leave him for a while. What's this? Anybody want some money on that? So that's probably that brown alga I mentioned. You should be able to recognise it by now. It's been carried in on this very gentle flooding tide. Oh, here we go, another seagrass patch. Is it remnant? I can see green. We can see green, can't we? We can see shell. We can see that it's all elevated from the material around it. So obviously it's doing that very good sort of baffling job. But the question is, can it survive? Will it live? Let's look up close again. Oh, I see hope. I don't know. I'm trying to see if there's any green. Am I dreaming? Am I dreaming? Look at the root systems. They look like they might be alive. Hard to tell. See the redox close to the surface and all the shell fragments have been trapped. So it's like doing a super job of baffling the water velocity and slowing the current down and causing stuff out. See how it's raised compared to all of the shore around it. So that's the power of seagrass. Remarkable stuff, but I hope it's alive, but I just don't know. Yeah, I'm gonna get shot by any botanist watching this. But really I haven't found a seagrass bed yet other than dead ones. I'll try and find something another day. Now this is probably Cymodocea, I'm thinking. And Cymodocea, this would be a subtidal seagrass, and obviously it's broken off and washed in. And you can see that sort of effect there. It's a reasonable one to describe, but basically at the base it's fairly green, and then further away from the base, that direction over here, it's darker coloured. So there's a basal meristem down there pumping out new grass material, much like your lawn at home. And then the bits further away from that meristem are the older bits, and they've got lots of stuff accreting on them, they blacken and die and basically break off and add to the detrital pool, while their seagrass shoot lives to fight another day. Yeah, this one won't. Alright, another depression in the sand. Who knows what caused it? Could have been a stingray. Not going to put money in it, but again, look at how that depression has led to the accretion of all that shell material. Quite amazing, really. Look at it all fairly fine as well. And a layer of fine mud underneath. Another one over here. Same story I mentioned early on. We're talking about those ripples. So the water drains out, and then basically the water drops through the beach and leaves behind this sort of clay, muddy kind of material. Fascinating. Alright, good one. We're just debating this whole situation. This one's, as Tamara's indicated, is pretty deep. I don't get why someone would bring a shovel out here and start digging around randomly. I think Tamara's right. I think it's stingray action. Just not terribly coherent. The water flooding over, you can see it's formed those ripples. It's obviously moved the sediment since that hole's been made, so it's obliterated a little bit the signal we might see on a different shore. Another one just here, about the same scale in terms of diameter almost. So yeah, I'm buying stingray action. Just reminding you where we are on the shore. Travelling back up towards where the car is, and let's look at some mangroves. We're just having another interesting debate. So again, in terms of interpreting this, could it have been children on the shore? Well, they had to wade out to do this because the hole must have been dug with water over the top of it for ripples to be able to form around the edge of it like that. If it had been a child digging on the beach, you see a pile of sand around it. So yeah, I think we're narrowing in on something that was submerged made this hole. If I was in Europe, I'd say swans. Here, I'm going stingrays. Here I got a line of them here. This is like signature stingray stuff moving across, working its way across, digging holes, looking for prey. Marvellous. Again, as a reminder, the stingrays use that principle of water motion to dig these holes. They don't have little hands to do it, buckets and spade. They use their wings in association with water pumped through their gills to dig holes. Having first identified the electrical fields of a submerged organism, using their Ampulla lawrenceni electrical sensory system. Nice. But again, here look, we've got soldier crab activity. Gives another date on it, but soldier crabs don't feed at high tide. We're also getting some sargassum here amongst the shell fragments. So this ray pit is doing a good job of locking up some of the nutrients in the beach, which we're finding when we dig down and see a bit of redox action like that. Right, a little darker sediment. Not as dark as Manly the other day, but definitely dark sediment. So we've spotted another seagrass patch. Again, it looks moribund, not doing very well. So wander over to it. Oh wow! Oh no, it's alive! It lives! Intertidal Zostra capricorni doing its trick, and the pugs have found it. So you can see that the bed is elevated around the profile of the rest of this this channel, but it's doing really well. Look at that, lovely seagrass blades. Again, Zostra capricorni. Some call it mulleri. I'll ask Kath for definitive on that. It's doing pretty well here. So yeah, again, wave action can't be that massive here. Protected by those outer banks, and then here the seagrass provides a very stable shelter for small organisms, and this channel we're in looks fairly stable. So beautiful seagrass bed, really nice to see, and hopefully the others improve with it. But here you'll notice the difference is these seagrass blades are submerged at the moment, so having lots of opportunity when the tide is low to do some photosynthesis, whereas the other ones were, well, I suppose they could as well. Don't know, I'll have to ask Kath about that one. Oh, let's look over here, that's a clue. Ooh, see the rhizomes there, running through. The rhizomes, beautiful. Runners going out here, lovely job. But over here, we've got a dead bit. So, when the seagrass blades are covered, they're doing really well. When they're a little bit too high and out of the water, the blades are basically dying off. A bit sad. Yeah, same seagrass bed. Okay, from one part of it, healthy seagrass, and where the seagrass is fairly dense, just here, even though it's out of the water, it's looking still fairly healthy. And then here, where it's fully out, that's so good. Trying to think of a theory for this one. No, I think we'll leave that to Kath. There's another couple of things. There's a hole there. What's that about? Another one there. There's another one there. There's another one there. What's that about? Happy with somebody to give me some guidance on that one. Nice clamshell. Not broken. Nice little clamshell. Lovely. Gorgeous, pick it up. Oh yeah, beautiful. I'm hopeless with bending invertebrates. I'll have a hunt when I get back. And I'll see my Moreton Bay guide. Lovely shell. I got one. So here's no, I don't have the lid with me. So here's the holes, and some have been popped out. So crabs have been around. I caught one, soldier crab. There we go. What's he gonna do? Oh, he's digging a hole. He's digging a hole. No, come back. Do it again. No. Come back. Wow. Oh, it's gone anti-clockwise. Nice one. Clockwise or anti-clockwise? Which way you start them off? I don't know. I can't remember the rules here. We're in the southern hemisphere. Oh, come on. Don't play dead. No, he's alright. Oh, she is alright. Come on. Stop sulking. Okay, sulk. I'm going for another one. From there. No, alright. Not like it, is he? Alright. Yeah. My one random crab. He'll be fine. I'll pop him down a hole just to say don't worry. There we go. Nice. So, another Scopimera outbreak. If you look here around the burrows, you'll see little scrape marks. Those little scrape marks where the chelipeds, the claws of the crab, have scraped up the sediment, passed it through its mouth parts, and then dropped it down again. So that shows you bioturbation action. The other bioturbatory force is the holes the crabs are digging themselves. So those balls are possibly Scopimera, might be Mictris, don't know. It's not really a central burrow. I suspect Mictris, the soldier crab. Maybe, just maybe, we get a herd up. No. This again is Mictris soldier crabs. Doing a great bioturbatory job driving down that redox layer. Oh, someone just went down a hole. I'm backing up and stopping back within a minute. Yeah, we just saw one of the culprits scuttling away. This is Mictris action. Some of the crabs have been up on the surface feeding. Others that are pushing up these mounds are basically feeding below the surface. And some have been arrogant enough to pop out of their holes and start running around making these little claw marks on the surface of the sand, which you can see. They seem to be feeding on the ridges. What's that about? Why would a crab feed on the ridges and not... maybe the clay's the problem, I don't know. But see, all the crabs seem to be feeding on the sides or tops of the ripples. I can't see much disturbance to any of the other stuff. The base of the ripples where that clay material is, maybe that just screws around with their mouth parts. Maybe this is a ripple thing because they know how they can predict the size of the particles of sand they're going to be processing. But I reckon that's an interesting observation. Oh dear. Challenging. Back soon. Well, this is a bit more stingray-like. Notice how the stingray, the sort of shape of a stingray there, and then one wing, that's the sand pulled out by one wing, and then sand pulled out by the other wing, so the ray would have been facing this way towards the ocean. Still some water in the pool, so still a little bit of a service. So yeah, habitat engineers, stingrays, habitat engineers. Let's wander on a little bit. I'm just gonna hope you can see what I can see. Can you see what I see? As I walk around here, there's little ripples in the water. Tiny little something or others doing something or other, but without a very, very fine net I can't find them. Here might be a Polynices, let's see. Oh yeah, we've got one. There's the trail leading back, and there's Polynices, the leaden. Actually, is it Polynices? No, it's Nacerius. Sorry, I screwed up. That's Nacerius. That's a big whelk. So I can't remember what Nacerius it is, but I found a little one earlier on. It had its proboscis sticking out. It was wandering around. So I thought these tracks were all made by Polynices because we found the egg cases, but indeed it's actually a dang whelk. So I'll see if it moves. I'll get back to you if it starts doing stuff. Alright.
Where are all the crabs?
My assistant just pointed out to me that there's a mangrove root. Here's a mangrove. It's Avicennia marina again, or Pneumatophores. You're familiar with that. Pneumatophores here aren't very large. I wonder why that is. Could they be being inundated by sand? They're obviously doing the accretion thing pretty well, slowing the current velocity again. What's the story? Or don't they need it because the sediments are much more oxygenated than elsewhere? You can see for this tree here, the pneumatophores extend quite some distance. But here, there's a little sad tale of a dead one, and you can see that it's provided some living surface for barnacles. They got quite large. Those barnacles are getting pretty big. And also some boring organisms have drilled into it, maybe something like shipworm, teredo. The holes are quite small though for a teredo. And then down the base we've actually happily got some green algae, maybe they're Enteromorpha, Alvarigida, whatever. I'll have a chat with Kath and see about that. Just have a look at the little holes and we're going to talk about something else. So I'm looking at this and I'm thinking these holes. This is actually, I think, the barnacles are growing out as they get smothered or out-competed by barnacles to their side. They're growing towards the surface. These ones here are alive. They've got their little plates closed up. If the tide was in, they'd be out and filter feeding, of course. And then you can see some of the structure of the barnacle shell, those plates. If we look over here, there's some that have been knocked off, and so those seem to be growth rings of barnacles, as the barnacle has grown up to stay at the surface so it can still continue to filter feed. These two here have been knocked off. I'm pretty sure these holes are a story of barnacle growth, and I didn't know they did that, so, but I don't know much. Very interesting. Great. So we're in the middle of that crab zone again. Just want to point out there's some large balls, which are wonderful, and those are just where the crabs excavated the burrow. The small balls are where they've been processing the sand, the sediment through the mouth parts, and then floating out those detrital particles I spoke about on Manly the other day. Here's a little bit of rock here for somewhere or other, and it's covered in barnacles again. And you can see the barnacles are alive because they keep these little holes amongst the sediment as they open and shut. Nice. Nearly tripped over an ensis. There's a razor shell. No, hang on, which I'm photographing the wood. It's a razor shell, razor clam. Live vertically in the soft sediment, soft sediment out there on the sand flats. Some of the depressions we saw are probably these things. So, ensis, they're bivalve. Caught the fiddler crab. I thought it was like a shed claw, but it was just a fiddler crab. This is unusual because they like to live in. Of course, they make burrows, but they don't do very well at burrowing fast. They rely upon having a burrow. So if one's chased away from a burrow, basically it's toast. This one doesn't know what to do. He's trying to attack me, but I'm not causing him any grief, I don't think. There's any power in that claw. Oh! No, I don't want to find out really. Ow! Yeah, there is. Never do that, alright? Never do that. Come on, buddy. This is a male, of course. The females don't have these large chelipeds, which are only for display, that you can't feed. How would you, try and imagine eating a pizza with that. You'd never get it near your mouth. You'd be sticking it over your left shoulder all the time, right? So, it's not for feeding, it's just for display, threatening other crabs, maintaining the middle of the territory. The little claw is for feeding. So what impact do you think that has on the rate at which this crab can feed? The other thing about it has the stalk eyes. See the stalk eyes there? So this crab doesn't care. This crab cares about what's coming towards it while the tide is out. And those stalks stick up, so it's got a long range of vision. While it's feeding, it doesn't ever see its food because it's always staring at the distance, seeing if something's coming up to it. And that little claw is just going to be shoveling food into those mouth parts you can see that are bubbling at the moment. And that's going to rotate that food ball around and float out the detritus. And then good night Vienna. The other thing, if you look below, is that narrow abdominal shield. So, if we didn't know from the claw, we'd tell this is a male. The females have a broad abdominal shield to make sure they can hold the eggs. Alright, pop them back so it happens. The buddies are out. Oh yeah, bunches of crabs out. Alright, so we'll leave this one alone. And then just make a comment here that we've got edge of the pneumatophore zone. There they go. Bye-bye, 5 meters, something like that. Blue and orange claws, beautiful things. Popping down their holes. So they're dragging a lot of, with this density of fiddler crabs, probably a lot of oxygen getting down there. And as you know, the pneumatophores, their principal function is to act as an entryway for oxygen into the root system of the mangrove, because the roots are buried in anoxic soils. So the pneumatophores are vital. They have little lenticels on the surface of the pneumatophore, covered in like a waxy compound which is hydrophobic, so it just deters water entering. I think that's the story, Kath will correct me. And then air can enter and everyone's happy. Alright, so pneumatophores. But I mentioned the other day that the transition zone between the sort of mangrove area and seagrass area is about mid-tide level. And what's that? It's Ostrocapricorni, intertidal, looking pretty happy, even though this stuff's it's not submerged, it's not looking all knocked about like the other stuff we saw on those further out banks. So low energy environment here. There were two crabs having a tussle just now, but oh no, it's a Nacerius feeding on something. It's trying to attack whatever that is. I'm going to find out in a minute. That's where? No. It's alright. Just trying to find out what the Nacerius is having an attack at. Oh. Tibbetts puts his glasses on again. So you can see Nacerius the whelk. There's the hermit crab. That's in a whelk shell as well. Nacerius is cruising around, and it's come across something here which we're going to explore in a minute. So there's a hermit crab there. That's in that's in a serithid shell by the look of it. Or is it a serithid shell? Which on here? And what is going on here? So the whelk, dog whelk, Nacerius, the black one with the siphon out, seems to be approaching something that's lying here. Let's see what it is. Oh, it's a mud whelk. We saw some of those at Manly the other day, crawl around the shore, eating the detritus. We can tell it's alive because there's an operculum there, that black thing. This thing's covered in snails as well. It's got some barnacles on it. There's another whelk, kind of whelk. And that whelk's probably feeding on a barnacle. Yes, it was. It was feeding on a barnacle. I disturbed it. That's what the whelks are after. They're after the barnacles. Bless them. And there's the other whelk that's fallen off, and that's Pyrasus, the mud whelk. Poor thing. Been a bit besieged and beset by snails. Well, can't always love your relatives. Realised I've been walking past what I thought were little rocks, but they're not. They're these mud whelks, and they're absolutely covered in barnacles, which is really unusual. I've never seen that before. Here's my finger. There you go. One there, one there, one there. And here next to it is another one of those little Nacerius, just waiting for its opportunity when the water comes back to crawl up on there and eat barnacles. What is going on? Running out of battery soon. So here's some roots. Here's a cluster of nematophores running away from this Avicennia. Let's take the lens a little bit just in case. And barnacles attached to them. So provide a site of attachment for things. But some of the roots, some of the horizontal roots that run, these runners, lateral roots, are exposed. The sand's been washed away, so that's not so good. And over here, some of the mangroves are looking a bit unwell, a bit poorly. Some of them seem to be long established here. I mean, these are significant trees, but they've got dead bits on them. There's all the crabs in front doing their digging. Look at that, dragging the nutrient back down the holes. Wonderful. When the tide's in, these will all be gone down the holes. They will not be anywhere near the surface. Get picked off by a bream. Look at that dead zone under this poor mangrove tree. What is going on? More of the Pyrasus. It's having a tough time. I don't know. Green shoots here and there. I don't know. Being attacked by insects. I see something nibbling away there. Oh, I can't see it nibbling away, sorry. I can see the effect of it having been nibbling. That is the loss of leaf material. This bit seems to have dropped off. No, maybe not. There's a silly story. Maybe it floated in from somewhere else. Anyway. Alright, we've got a couple of Nacerius, and they're there in front of me, and they're having a bit of a chat. Oh, what's it doing? It's flipping itself over with its foot. Now, are they fighting or mating? That's the question that's being posed. I wouldn't mind an answer. They're just there, so I'm just going to finger for reference. I've got my glass on again. Look at that. Great Nacerius action, whatever it is. And it's love or war. And if you look around us, there are others. So the Nacerius are on the move. There. There's another one over here. They're making traps. One there. So Nacerius is certainly doing pretty well. Just there. Everywhere. Yeah, hunting for food. Pyrasus track. And then Nacerius there, cruising over the water. Wonderful. lot of snail action now. Very, very good. Finally, well, not finally, this is finally, let me do finally yet. There's a Polynices. So that's a lead and moon snail. That's the thing that makes those egg masses that we were looking at earlier. Alright, so lead and moon snail. I found it was cruising just underneath the surface of the water. Just very, very close to the surface. You couldn't see the shell itself, all you could see was the track. And then like a flattish thing around the edge of the depression, and that was the foot, which is a very large foot when it extends out. But Necarius. No, it's not bloody Necarius, it's Polynices sordidus, sorry. I'm getting confused. Polynices sordidus. And it's just starting to dig, it's moving its foot out now, it's just starting to push the sand away. And all it'll do is just bury under the surface, and it cruises around looking for bivalves. There it is, just digging its way in. Dig its way in. And there's a tiny, tiny hermit crab just next to it. Minuscule hermit crab, the smallest one in the world. And some halibates moving around. And there goes the old lead and moon snail, Polynices sordidus. Tiny hermit crab there as well. Look at it, it's so cute. There he goes, gone. Bye bye. Bye bye. Why is this a story about barnacles here? All the snails seem to have barnacles on them, yeah. So here's Ostracochlea porcata. I don't know what the common name is, I'll look it up. And then these might be Bembicium nanum, I'm not sure. But they've all got barnacles on them, and I haven't seen that much before. So what is it about this place that barnacles seem to be playing a major role? To figure it out. Anyway, crazy. So there are some grazers here, short, sharp, but they're being plagued by barnacles. Check this out. This is like I'm at war with a crab, right? So this is Portunus Armatus again, and he's ready for battle. He wants to have a piece of me. Hello, I'm here. I'm invisible. You may not see me again. Oh, no, he's gone actually. He's actually gone straight into the seagrass, which is kind of an interesting thing because juvenile sand crabs love seagrass. So great, it's a nice nursery habitat for them. That reminds me to talk about habitat connectivity. So obviously if you've got, you know, a lot of people tell you mangroves provide great habitat for small fish and that sort of stuff, and obviously there's lots of food here. The food is generally very small stuff that's moved, that's driven up by the redox zone. You see my footprints here. You'll see that basically the redox zone is right up at the surface. We've got seagrass, pneumatophores, stable environment, fine particles, lots of detritus, so the redox layer is right up at the surface. So that drives all the small creatures, well, everything that requires oxygen to respire, up into the surface layer, so that makes it available. I've got a trick I'm going to try tonight, trying to see if I can show you some myofauna when I get home with a little sediment sample. But in terms of habitat connectivity, the crab hid in here, in the seagrass. It was foraging around the pool, which is near the pneumatophores. But if it wants to get to deep water, if that crab or other juvenile creature wants to get to deep water, it's got a long way to go. If we had, for example, mangrove habitat, nice complex mangrove habitat, then we had a lovely seagrass bed abutting with the bottom of the pneumatophores, and then below that a subtidal seagrass bed. Imagine that pathway would be so much stronger than a pathway where you had this huge open shore for things to migrate across. So yeah, habitat connectivity is really important in terms of linking mangrove, seagrass, subtidal seagrass, coral reef habitats. And these sand areas are a real specialist trick. Getting out there is tough. Imagine the little fish on every tide. Yeah. So, here we are, close to the top of the shore, just a few metres away. I was telling you how many, all those pyrazes were covered in barnacles. And then here, there are pyrazes with no barnacles on them. None of them. So a few metres away, near the mangrove trees, and there are lots of barnacles on the mangrove trees, there were pyrazes absolutely plastered in barnacles. And here we are 20-30 metres away, and they're not. What's going on? Write me an answer. Is it something to do with barnacles? barnacle larvae and their distribution? Don't think so, but we'll look into it. Come on, okay, behave. Here we, oh no, where are they gone? There they are. We've got hermit crabs having a bit of a party, a shell spot. Another one's coming in. Oh no, it isn't, it's wandering out. Oh yeah, you've seen them, They're all in there trying to swap shells. So they'll be arguing about who wants what shell. And the biggest one, I don't know, the more powerful one will drag one out of the shell and then swap it. So these hermit crabs don't grow their own shells, of course. They've got to find mollusk shells, which dwell, particularly gastropod shells. So they really need to make sure they can find a home to protect themselves. And that's why these little parties are all about that. They're all too young to reproduce, pretty sure. This is all about shells, like a shell game, I suppose. There you go. So here we have a Pyrasis besieged. It's got a huge oyster on its back to be a pain, and also some barnacles. Then over here there's a Pyrasis that once was, but now is occupied by a large hermit crab. The barnacles still surviving. So basically a crustacean inside a mollusk shell with crustaceans on its back. Pretty fancy. Now, this isn't barnacles. I'm pretty sure this will be shipworm inside the wood. Teredo, the shipworm, it's not a worm, it's a bivalve. But it basically lives in marine wood and used to cause great havoc with fleets, wooden hull fleets in days of yore, and shipworm are a major problem, drilling holes in it. I'm not going to break it apart, leave it here. So I'm just at the end of a road near the beach, behind the beach in Nudgee. I just thought I'd show you the mangrove forest. This is a creek that runs down Nudgee Creek, I suppose it was. I don't know. This is the transition zone between the land and there's no. These are succulents. These are plants. Sporobulus? Not sure. Anyway, they're succulents. They're salt resistant. Okay, so they're quite happy in salty environments. And then we go straight in the grass and lawn and that sort of stuff, right? So that's the absolute boundary between the marine environment here and the shore. You can see a crab hole there. Several crab holes. And I think it's Sporobulus, not sure. And then mangroves. And then Kath will have to do that one for me, I'm not sure. I'm not going to put my name on any of the identifications of these things. Other than that one in there. It's got slightly rounded leaves. What's that about? But those in there are Avicennia again. You can see the pneumatophores sticking up and baby mangroves. And you can see how dense the mangrove forest gets. We're just seeing the fringe. I would have a walk around, but I won't. Yes, I will. Why would I not? Anyway, let's carry on. More of this. What I call Sporobulus, I don't know. I don't know if you can eat it. It looks like you could eat it. That's rather nice. This yellow one, is that Cereops? I don't know. Kath, save me. Oh, he's going maybe Cereops. I can see this sort of, we're going into sort of a mud flat area. The creek's in the distance over there. See the creek in the distance. And basically a solid wall of Avicennia. And then some interesting ones, which I'm not sure about. I've seen pneumatophores here, so I'm diagnosing those as Avicennia. These have a brighter yellowy leaf. I'm going Cereops, but I don't know. I just don't know. It's not bright enough. I don't know. Maybe. Another kind of salt marsh plant as well. I'll dig that one out when I get back. And so we've got mangrove, sort of salt marsh flat here. And then we've got salt-resistant plants, like the succulents here. See the succulent quite rounded in their leaf form. Ooh, let's fill a bit up here. See the leaves are somewhat cylindrical. So has a very low surface area compared to the volume of the leaf, which unlike most other leaves, so we take a grass leaf, it's got a very high surface area compared to the biomass or volume of the leaf. So, yeah, so marsh flat also has crab activity here. Could you believe it? There's little crab holes everywhere. Yeah, and there's signs of crabs been working the surface of the sediment. So same sort of processes, different set of players probably. beautiful. Alright, so the transition zone between the land and the sea. What is this? I don't know. Another something or other. Again, it's fairly rounded. It's succulent. Looks like you'd eat it. Can you eat it? Possibly. I don't know. It didn't work out well. Anyway. Yeah, fascinating stuff. Alright, toodaloo. I showed you the creek before, okay? This is actually the ocean side, so this is the other side of the beach we were on just a little while ago. And you can see here we've got a very dense stand of mangroves. There's some standing water there as well, so there might well be little fish and things in there. We know the tide's well out still. And then as you come across, you've got, is it samphire, sporobulus? Oh, dig this one out, you know. And then we've got this like transition zone of salt hardy plants, including some grasses. And then we're basically onto terrestrial vegetation, fully terrestrial vegetation, which is, you can see behind me over here, some casuarina, some eucalypts. Ordinarily, if it's a swamp, we've got a creek right next to us, so the creek's just the other side of the road. So there's really no area for a water table to establish here and support paper barks, which we'd normally find in the transition zone. Anyway, how splendid. Lots of Moreton Bay guy looking for me. Crab holes again, pneumatophores. Great stuff. Alright. He's still going on about these mangroves, but look. Grey river mangrove, grey branches, grey-green leaves, yellow, bright green. Slightly different leaf shape. Tell me it isn't Cereops. Can't see any large ones though, so yeah. Nothing to look at the base of the tree to have a look at the roots, crop roots or whatever.